Welcome to the project demonstration of state of charging of electrical batteries. So here let us see the battery ratings. So we are using 12 volt 2 amps battery. So these are two battery packs are connected in parallel. So each battery pack consists of 4 volt 1 amp. So these are the dry acid batteries. So these three batteries are connected in series, 4 volt 1 amp. So into 3 is of 12 volt 1 amp, and these two are connected in parallel, so that we will get the maximum power. So there is a 2 amps, so 1 amp and 1 amp are connected in parallel, so we will get the 2 amps as a 12 volts. So this is a rechargeable battery. We can recharge this battery from this charging circuitry. And also here, whenever we are connected a load, DC load to this battery, so then we need to check the state of charging and discharging with the help of this Arduino Uno board, as well as if is there any temperature increasing, we are going to measuring that with the help of LM35. So here, while measuring this SOC, state of charging, we are making use of different kinds of, we can use a different kinds of methods. So in our project, we are making use of Coulomb counting method. So that is, for every counting, we are going to measuring the existing power inside the battery, nothing but existing voltage along with current, and also what is the state of battery before connecting the load. So we are going to comparing that too, and we are finally calculating the remaining power which is there inside this battery before switching on the load and before connecting, after connecting the load. So we are going to measuring the voltage and current from this sensor, that is a potential divider circuitry with shunt. So here we are going to dividing the voltage with 10:1, and from that we are going to reducing the voltage, which can be understood by our Arduino Uno. And that was connected at A0 pin, and LM35 is connected at the A1 pin, and buzzer is connected 12th pin, and this MOSFET circuit to control this load based on the input values, so that was connected at 13th pin, and the LCD is connected at 2227. So this is the breadboard in order to distribute the 5 volts power supply throughout this buzzer and modules. And next, so coming to the charging circuitry, so we are going to provide the 230 volts AC here, and from this transformer we are going to get the 12 volts AC, and after that there will be a 4 diodes are connected in a pattern of bridge rectifier. As we know that after bridge rectifier we will get the pulsating DC, and in order to remove the pulses, we are making use of one capacitor of rating 1000 microfarad, and there are the 2 diodes which are connected in forward bias from the charging section to the battery, and it will act as a reverse bias from the battery to the charging circuitry. Why? Because if the battery is getting fully charged, so then it is going to be the high potential one, and the transformer section is going to be the low potential one. In order to oppose the current flow from battery to the charging circuitry, to secure this charging circuitry, we are making use of these 2 diodes, and this one is a resistor with 1 kilo ohm, and for the LED current limiting resistor. And so the flow is, as we discussed, that output voltage 12 volts given as main charging circuitry voltage to this battery, and when we switch on the kit, so initially 15 seconds it will calculate the power, voltage, current, and along with the temperature. So it will make some data set kind of thing, and after that 15 seconds is completed, we are going to switch on this load. So from there onwards we are going to calculate the, based on this load, how much of power is left in that. As we know that the battery ampere rate we can measure in mAh, for example milliampere per hour, that is normally power. So but coming to this SOC, we need to multiply the I, and next is the current, okay, and that will be calculated and that will be displayed on this LCD screen directly. So let us see the demonstration. So just give the main power supply, or else directly, this is charging section 1, or else directly you can switch on the low directly from the switch. So there will be a welcome message on the screen, we can see that, and now we can see that there is no data here is connected, okay, card. So now there is no data is connected. After 15 seconds, now the load is got switched on, and we can see that. So based on that load, how much of power is left and how much of voltage is left. So it is keep on decreasing when the load timing is increasing. So for every operation there will be light indication on your Arduino Uno board. We can check that. And the temperature, we set the temperature for 50 degrees. So when the temperature increases 50 degrees above, so it indicates as there is abnormal condition, and light will be off, the load will be off. So we can check that, right, and high temperature will be displayed. When it is coming to the normal, again it will coming to the normal position. Right, if it is below 50 degrees again, the load will be connected, and based on that again it will start calculating the remaining power inside this battery. Okay, yeah, thank you.